Hello students, today we will see the second type is unguided media and this is also known as the wireless transmission. This unguided medium transmission media provides a means for transmitting the electromagnetic waves or signals but do not guide them. And this is for example wireless transmission. An unguided transmission transmit the electromagnetic waves without using any physical medium. So this is called as the wireless transmission. This signal broadcast through free space and available to capable receivers. The characteristics and quality of the data transmissions are determined by the medium and signal characteristics. For a guided media, the medium is more important in determining the limitations of the transmission, while in case the unguided media, the bandwidth of the signal produced by the transmitting antenna and the size of antenna is more important. That means here we see the transmitting antenna and the size of antenna is more important than the medium. This unguided media is used when running a physical cable, that means either optical fiber or the copper wires between two ends and 2 points. It not possible. Here transmit electromagnetic waves without using the physical path, which is also known as the wireless communications. And here the signal are normally broadcast through atmosphere or the air and thus are available to device which is capable of the receiving them. See, this is the figure. Here a radio wave and microwave. Then a second is infrared, and here this is the light wave. This figure shows the part of the electromagnetic spectrum ranging from 3 kilohertz to 900 Hz. That means this is the use for the wireless communication. Here this is the unguided signals can travel from the source to destinations in several ways: ground propagations, sky propagation, and line of sight propagations. Here propagations methods, there are three methods. These three methods having these are the three diagrams which are the some representations. Like first is ground propagations. This is the ionosphere and ground propagation. Second is the sky propagation. This is also ionosphere and this is also line of the propagations. It below 2 megahertz, then it is 2 to 30 megahertz, and this is the above 30 megahertz. And then we will see one by one. First is ground propagations. These radio waves in the band propagate in ground surface, ground or the surface wave. The wave is connected at the one end to the surface of the earth, to the ionosphere at the other, and ionosphere is the region above the troposphere where that means air is available. This is called as the troposphere, from about 50 to 250 miles above the earth, and ground waves travel between two limits and the earth and ionosphere, which acts like the duct. Then in ground propagations, radio waves travels through the lowest portion of the atmosphere, touching to the earth. See, this is the earth. Here signal propagations, here transmit antenna and receiving antenna. Then second is the sky propagations. This is the higher frequency radio waves radiate upward into the ionosphere and are reflected from the ionosphere. While the wave in the ionosphere, it is strongly bent and refracted ultimately back to the ground, and from the long distance away from appears as a reflection. Long ranges are possible in this mode also, and it is the hundred of miles. Sky waves in this frequency band are usually only possible at night, when the concentrate of the ions is not too great, since the ionosphere is also tends the attenuate the signals. See, this is the ionosphere, this is the earth, and this is the sky propagations. Here transmit antenna, then signal propagations and receive the antenna. Then third is a line of sight or inline or side propagations. It is very high frequency signal are transmitted in the straight line directly from antenna to antenna. Here signals above 30 megahertz are not reflected by the ionosphere, and here it is transmitted based on the line of sight concept. And see, this is the diagram for straight line propagations. This straight lines directly from the antenna to antenna. This is one of the antenna, this is one of the antenna, and this is the signal propagation. This is called as the line of sight propagations. Then wireless transmission wave. The wireless transmission can be divided into the three broad groups. First is a radio wave, second is microwave, and third is infrared waves. Then we will see one by one. First is radio waves. The electromagnetic waves ranging in frequencies between 3 kilohertz to 1 gigahertz are normally called as the radio waves. These radio waves mostly are omnidirectional, as shown in this figure. See, this is the diagram for radio waves. Radio waves are produced when an alternating current flows in an antenna. When an antenna transmits radio waves, they spread out and travel through the atmosphere. This is atmosphere and propagated in all the direction. So these waves are received by another antenna used as a detector. These radio waves produce an alternating current and with the frequency that matches that of the waves. So this is sending and receiving antenna do not have the align, and radio waves, particularly those who have propagate in the sky mode, can travel a long distance. So radio waves can be used for the long distance broadcasting, such as AM radios. Here this is the radio waves. This is an omnidirectional antenna. These radio waves, particularly those of low and medium frequency, can penetrate walls. For example, AM radio can receive signal inside a building, but we cannot isolate a communication to just inside or outside a building. Here this is the radio waves can penetrate building easily, so that widely used for the indoor and outdoor communication. This is also communication like radio, television, and paging system. This having characteristics like less sensitive to attenuations from rainfall. Maximum distance between transmitter and receiver is given by same equation as like microwave, same for the attenuations. These radio waves are electromagnetic waves which are transmit in all the direction. Free space. This is a ranging frequency 3 kilohertz to 1 kilohertz. Then here not kilohertz, this is 1 gigahertz. And here applications of radio waves. A radio waves is useful for multicasting when there is one sender and many receivers, and FM radio, television, cordless phones are example of the radio waves. Then second is microwaves. Then electromagnetic waves having some frequencies between 1 to 300 gigahertz are called as the microwaves. Here microwaves are unidirectional, and microwaves are ideal when large areas need to be covered and there are no obstacles in the path. Here electromagnetic waves having frequencies between 1 to 300 gigahertz called as a microwaves, and these are the some transmission characteristics. One of the first is microwave propagations is a line of sight. Then repeaters are often needed for long distance communication. And third is very high frequency microwave cannot penetrate walls. Then unidirectional antenna. An antenna can be defined as the electrical conductor or a system of conductor which is used for either for radiating electromagnetic energy or for collecting electromagnetic energy. Here the microwave needs unidirectional antenna that send out signals in one direction, and two types of antennas are used for microwave communications like parabolic dish and the horn dish. These are the two types of the antenna which are used for the microwave communication. Parabolic dish, it is also called as the dish antenna, and second is the horn antenna. Here this is the dish antenna and this is the horn antenna. First is the dish antenna is one of the most widespread of all microwave antenna, and the dish is not actually antenna but serves a reflector, and it must be driven by a radiating element at the focal length, and this radiating element could be dipole or horn radiated, and it is basically geometry concept of the parabola. And a parabola is a mathematical curve such as its reflection property causes an incoming beam of the parallel rays to focus to one point and constantly radiate waves from the point signal placed at focus point that are reflected by the surface to form parallel rays in outgoing beam. Then second is horn antenna. This horn antenna derives its name from the characteristics flared appearances, and the flared portions can be sequenced in square, rectangular, cylindrical, or conical, and the direction of the maximum radiation correspond with the axis of the horn, and the horn is pointed toward the center of the dish reflected, and the use of horn at the focal point of the dish which is minimize the loss of energy around the edge of the dish reflector, and horn antennas have excellent gain and directivities. Then third is infrared waves. Here infrared waves lies between the visible light spectrum and microwaves. It has a wavelength of 700 nanometer to 1 millimeter, and frequency ranges from 3 gigahertz to 430 terahertz. Then this is the can be used for the short range communication, and infrared communication is achieved using the transmitter and receivers like receiver, and that module the non coherent infrared light. This is the infrared wave which is used for very short range communications. Example like night vision camera, remote control, file sharing between two phones, communication between PC and peripheral devices. Then here the comparison between guided media and unguided media. Here the transmission between these two media. In guided, it is wire transmission in which data signals are guided along the physical path within a wire. Then unguided communication is the wireless transmission, and to exchange bits of the data for laptop, notebook and smartwatch without the wires, you need wireless communication. Then it is also called as the in guided transmission media called as the bounded transmission media. And then second is unguided transmission media is also called as the unbounded transmission media, and this is called as the bounded transmission media. Then medium type, some well known guided transmission media include twisted pair cable, coaxial cable, optical fiber cable, but in unguided transmission media it include microwave transmission, satellite communication, etc. Then media, the media can be seen and touched like tangible, and in the media is a wireless and cannot be seen in a touch, that is intangible. Then distance, used for the short distance and it is used for the large distance. Then penetrations, guided media cannot penetrate through the building, but in unguided media can penetrate through the building. Then next is a light wave transmission. In unguided optical signaling or free space optic has been in use of the centuries, but a more modern applications is to connect the local area network in two buildings via laser mounted on the their rooftops. Like a free space optical communications link, also known as the optical fiber link. Here free space optic, that means FSO, send and receive information using light but through the atmosphere instead of an optical fiber cable. It produces a narrow and a directional beam which is highly secure, and this technology provides the capacity of the optical fiber and uh, easily to installations. Here the moreover it operates in unlicensed spectrum and it provides a narrow and unidirectional beam which is highly secure. So this FSO transmit the data between building and that have a clear line of sight LOS connection, and it is subject to signal attenuation due to the weather conditions like such as fog, dust, rain, sand and heat. This is the typical FSO link consists of the transmitter, FSO channels and receiver. Currently FSO systems are uses LED or diode or semiconductor laser in the transmission lasing wavelength. Here the wavelength is 750 to 850 nanometer to 1500 to 1550 nanometers, and the laser can be either directly moduled or within an external modulations, and these receivers can have high detector based on the either pin diode or the avalanche photodiode. See, this is the figure, this is the modular circuit and this is the demodulator circuit. One of the here transmitter and one of the here receiver. This is the laser diode and photodiode and this laser beam which is directly modulated, and it can have high detector based on either pin diodes. This transmission convert electrical signal to an optical signal and send it through the atmosphere. At the receiver, optical signal is received and it is converted back to a electrical signal.